Hi there and welcome back to part 4. We're going to try and improve on this a little bit by rather than just working out the distance between the two, between the enemy and the player, we're going to try and be a bit more advanced and do a bit of a raycast so that we know if we're actually looking at it. This could be quite a long video, but we'll get on with it anyway. So the first couple of things you need to do is we need to I'm going to put all of these barriers higher a little bit, so the nav mesh will still work. We should, as long as we don't move them, everything will be fine. I'm just going to change their scale up to maybe 4, so that we definitely, when we're down at the ground level, we can't see through if we so we're able to test this properly, because what we're going to do is just cast this ray to the player and just check if we do this. The other thing that I found out through testing as well is that because we made this capsule has a collider on it, and because we're going to be using ray casting, we don't want to accidentally have the ray which we're going to start at the center of this to hit itself, the own collider. Now we could do it through layers and stuff, but for now, just if you untick that capsule collider or completely remove the capsule collider component, then we won't get any interference with that. So after that, let's get round to making the code. So this is the code that we had previously. We want, instead of doing this distance calculation and checking the distance to decide on whether we move states, we're going to need to find out a way if we can actually see the player or not. So what I've decided to do is the best way to do it would be if we create ourselves a new function. Now we're going to make a function that returns a value. It doesn't have to be public because we're only going to use it inside this class, but we do need to return a bool value, so that's going to return true or false, and we're going to call it can see player, and with empty parameters, so we don't need any parameters in here. We could make it more useful. If we need it later on, we could make it pass a parameter of a game object, so we could see if this enemy sees other things as well. So but right now we'll just leave it as that can see player, and we'll not pass anything to it. So you notice it's complaining because it doesn't return any values right now, and that's okay. We're going to get on with writing the code anyway and make sure that we do return the values. So what we're going to do is this can see player, we're going to have to do a raycast for that. So there's a couple of things I want to do first. What I want to do is I want to find the direction between the two. So I'm going to create a vector 3 and I'm going to call this direction, and I'm going to make this equal to the and I'm going to do some simple vector math. I'm going to subtract the player.position minus the transform.position. So what that's going to do is it's just going to subtract those two vectors, so it will give you the difference between the two, which should be a vector from one point to the other. So if I subtract that vector, the position here, from this position here, it will give me the position between the two of them, and that's going to be our direction. Now because I know I'm going to use this later on, what I'm going to do is surround this by brackets here, and I'm going to say dot normalize. Now you don't really need to know what that means, but what it means is basically we're going to create a 1 unit vector, so it doesn't matter how long this is, it's always going to be a magnitude of 1, so it's a direction rather than an actual direction and magnitude. So we've got the direction now we need to create a ray that we're going to cast. So I'm going to create a new ray. I'm just going to say ray and then call it small lowercase r for ray, and we're going to make it equal to a new ray. And there's a whole bunch of potential options that we can do for this. I'm going to use ray, comma, and then I'm going to use ray. I'm going to use the origin, which is the transform.position, and the direction, which we have already calculated from direction. I was jumping ahead of myself a little bit there. So now we're going to check that ray by using the physics.raycast. So if you double tap tab after you type in if, and then we'll just use physics.raycast. And this is where we get a whole bunch of options. We're just going to use the classic raycast. We're not going to call this a whole heap of times, so it should be okay, and there is a bunch of different potential options for this one. The one I'm going to use is just this one here, it's number 6. It is, so I pass in the ray, which is we've already made with ray. I pass in the data structure that I want to hold the hit information from. So the way you do this in C#7 is you just use out, basically copy what it says here, out raycast hit. I'm going to call mine hit. I could call it hit info exactly like it does in the help, and then we have the maximum distance. Now we did calculate the distance before, so this is a great way to just avoid having to do that as well. If we give a distance, we'll hard code it just now, but if we give it a distance of 10, then we know that the ray needs to be 10 units long, and it will only record hits along that 10. The way you get the hit information is from this data structure. So if the physics.raycast does actually hit something, it's going to fill out this hit data structure with some information. So the most simple way of doing this is if I just say if we've hit the player, so if hit dot collider dot tag equals, and then inside of quote marks player with a capital P, then we've actually hit the player. And if we have hit the player, we want to return true, because this is saying that we've actually hit the player. Now you see it's still complaining because it's not returned a code path, so it hasn't potentially returned false. It could have dropped out to here and not returned anything. So if we've got this far in code, it means we haven't already returned the value true. So we are safe enough right now to just say return false. So if it doesn't actually hit anything, it will return false. If it hits something, it will check to see if it hits if it's actually the player, and it will return true. Now we don't need to put a return false in here because it will just drop out and go to return false because it won't have returned. So kind of makes sense, I suppose. So this can see player function now will return true if it sees the player with the raycast, and false if it doesn't. So we can use it now. We're going to use it instead of here. So I might actually just comment this out just to prove it. So I'm going to say if can see player. The opposite one here, when we check that we're going to go into the other state and back into the idle state, then we're going to say if not can see player. Now the not is this is exactly the same as typing in if can see player equals false. You can have either one, it doesn't really matter. Most commonly you'll see the not can see player. Ideally we shouldn't call this twice, we should probably call it once, just like we did with distance, and then and cache the result into something, and then we could, well, we'll get this working and we'll do that. So these are make sure that these are high enough inside your one, and also make sure that the capsule collider that you have is removed, the collider component is removed, so that that array isn't actually hitting that. And then I'm going to hit play, and we're going to go back to the scene view, and I should move this guy, and you notice I'm close enough, but only when I get on the correct side of the barrier does it actually come and see me. So this works with a distance of 10 as well, so 10 units will make it move towards me, and 10 units will only work as long as it can still see you inside of the ray. Now there's one other, it's quite a long video already, but there's one other addition I'd like to add in. This is really easy to do. Often you don't want to see them if the enemy shouldn't be able to see the player if it sneaks up behind him as well. And it's a lot easier than it seems with a little bit of vector maths, because we've already got a direction here and we can work out what the angle is with the help of Unity. So we'll just quickly do that. So we'll basically say if we know here, if we get to this piece of code, that that the ray has actually hit the player. What we could do before then is we could work out what the angle is. So we could immediately not even do a raycast if the angle is beyond a certain amount. So yeah, I think we'll just chuck it in into here. So underneath once we have the direction, we can work out what the angle is. So we'll say float angle equals, and we'll use vector3 dot angle, which is takes two directions, or two vectors, and returns the angle between those two vectors. So it's only ever going to be, if you look this up in the help, it's only ever going to be between 0 and 180, because obviously if it's directly behind you it's 180 degrees, and so you go further around and it's going to get less, not more. So it's only going to be a maximum of 180. So what we're going to check is the angle between the current forward vector and the direction vector. And because these are both normalized, this will return that angle. And then we can use that to help us decide on whether we are actually visible or not. I think the easiest way to do this would be that we just continue with the raycast. We'll do the raycast, it's only getting done once a frame and it's only one ray. So we know that we hit the player when we get the tag of player. But what we should maybe do is say if you do hit, the raycast hits the player, and we'll do the and, so this means another condition inside this if statement, and the angle is less than, and I don't know what a standard angle would be. Maybe we'll try 45. And again, we've hard coded this. We definitely should make this a public variable up top, but for now we'll just give it a go, as well as that one. So if the angle, which we calculate every frame when we run can see player, is less than 45 degrees, then it should return true. If one of these isn't the case, then it'll drop out and return false. So we don't need to change anything else. We're working all within this can see player. So just so that I know what's happening, the forward direction for the enemy is the local blue line, so it's moving in that direction. So in theory, if I sneak up behind him, over here somewhere, I shouldn't be able to, it won't trigger, but I'm not entirely sure, so let's have a little look. So it looks like the enemy's forward direction is still that way. I'll click on the player and move him, and so in theory, yeah, he's not in front of him, so he's not moving forward, and only when he comes within 10 and there. So again, I could sneak up behind him and he can't see me, and then I get within 45 degrees and visible, and he will move towards me. So that's actually working pretty well. It's a pretty good system. In the next video, I'm going to add in the I think we'll get the spider in, and we'll maybe look at tidying up this code a little bit. We're only going to work on the idle and moving state, and then get the enemy in before we worry about the attacking. Alright, so hope you're enjoying the series, and look forward to seeing you in the next one.